Right, hello everyone. It's the first video of the pre-stressed concrete I-beam designed in the Lee Bridge concrete. I'm going through step-by-step process. I'm sure like everyone knows about these initial steps about giving the geometry. The precast length would be different than the release length. Bearing to bearing is 115. So 115 minus 116.667 gives you 20 inches, which is 10 inches outside of the bearing line. Material is pretty much common. Don't forget to check these material strength. That is really important. You can use this 5 and 7 KSI as per BDM, 7 and KSI if it is not working out. The longer beam length, let's suppose 100, 110, and the bike 220. We use 7 and 9 KSI. So the bridge I am working on right now is the Riddle Road. So I'm using 7 and 9 KSI as well. So besides that, the unit weight, everything is same, 150 pounds. The loads, precast DC is usually if you specify the haunch thickness as 2 inches and then width as 49 inches, it kind of takes the haunches here, which means it calculates the haunch load. So all you got to do in the loads here is give the overhang as camber, and then DC2 load would include everything that that is related to the uh, sidewalk and railing, and yeah, bridge railing, which is obviously bridge railing. Yeah, sorry. And then you put the future wearing surface, which is 60 pounds per square feet, and do the same thing for all the beams. When it comes to the diaphragm, so the diaphragm would be between the beams. You get the diaphragm locations from the framing plan and then put the loads 1.1, 1.5 or whatever it is, the load. Uh, Go to the beam design, do the analysis part. One quick thing in the analysis part is you don't forget to check this in. Uh, First thing we need to remember is moment and shear provisions, horizontal shear auto design. It should be intentionally roughened because the top of the beam surface would be intentionally roughened. And then in the multipliers, sorry, limiting stresses, have to go to the tension trigger step and then have to make sure this is 0.09, 0.09. This is as per the O.BDM specification. BDM says to consider that number as extreme corrosive level, so that's 0.09. Stand patterns is pretty common. Look at the standard drawing and then get the stand patterns, and then do the use the state and drape stands, and go to the wizard. And then if you wanna debond the stands at the ends, you can click those and then say debond, and then put the space, put the distance of the debonding. This is where you do it, and looks good so far. Analysis. The major important thing is in the rebar pattern, so you have to put these shear rebars. As per the BDM, the shear rebars, this 401 rebar is going into the deck. I'm looking at WF 5049. This 401 rebar is same for all the beams. 401 rebar is acting as an interface horizontal shear, and your main reinforcement is these D31 and D20 rebars. So this is an example, this hand 68, they used D31 at the ends is 3 inches, and then at 6 inches and 12 inches in the middle. So D31 size is number 5 and D20 is number 4. So C401 is the rebar which is going into the deck. This anchorage zone reinforcing steel, you have to come up with how far this 3-inch should go. So for that, there are some calculations from ASHTO. So what should be the anchorage zone reinforcement? It should be 1/4, h4 of from the end of the member, which means if your beam height is 54, then you kind of take 13.5 inches, round up to 15 to have the equal 3-inch spacings. Okay. After the anchorage zone, then you have two rebars at the bottom, 302 and 305. You continue those two rebars till the second anchorage zone, and then after that you just continue only one rebar, just like shown in the standard drawing. Says discontinue 305 rebar at a distance of 1.5 depth of the beam beyond the termination of the stand bonding. So what is 305 rebar? 305 rebar is your stop rebar here. Okay. Okay. Cool. Now you are putting these number 5, number 5, 4, number 5, number 5. So this is D31, D31, D20, D31, D31, and then you are putting these number 4 rebars which are going into the deck. This is 401 rebar, right? This is the rebar we are putting. So since it goes into the deck, it acts as a composite. So let's say you want to make it 12 inches here, 15 inches. Yes, you don't. I'm trying to match the spacing with the welded wire reinforcement D31 and D20. So if it is 3 inches here, 3 inches, it's matching. So it's 6 inches, 6 inches here. But I want to see by changing this to 15 inches rather than what we have here is 12 inches. Okay. You do that, go to the results, save view. Alright, this is where we are stuck. So vertical shear reinforcement is good. We don't have any issues with that. All clear. So the problem comes here is horizontal shear. So the horizontal shear, although you're doing this for the reference surface. Okay. For the reference surface, the software says the area of steel reinforcement required is 0. Okay. But ASHTO has some minimum requirements which is 0.49. If you go to the ASHTO article 5.7.4, that is the old one actually. So if you this is the actual one 5.7.4.2. You if you do this math, then you come up with the number 0.49. Okay, and then for the smooth surface 1.74. Okay, so since I'm doing the reference surface, should I compare this with the 0 or 0.49? So 0.49 is the minimum area of steel requirement, and 0 is for the rough surface. So I had a conversation with Brad and Chris Jackman. So we agreed that it should be compared with 0.49. So in my case here, it says red marking, which is why basic, which is the reason is 0.32 is less than 0.49. 0.32 is less than 0.49 here. But at the ends, remember, we have 6-inch and 3-inch spacing. But in the middle, I gave the spacing of 12 inches. So that is the reason that is less. So if I make this, I suppose 9 inches, I'll go to the results. Let's see. Okay, so it was fine. 0.533 is greater than 0.49, 0.533 greater than 0.59. So this number area of the steel provided should be compared with the minimum steel requirement when you're doing the reference surface. Let's suppose if you're doing the smooth surface, which is the preferable, then you have to take the maximum of minimum and then smooth surface, which is maximum of 1.79 and 0.49, and that your reinforcement provider should be greater than 1.79 here in the case of smooth surface. But we are doing the reference surface, so we are going to take the maximum of these two numbers, 0 and 0.49. So in our case, all these numbers are checks are passing. So couple of questions arise is like, can we have a different spacing? Because in our case on part 220, the number 4 reverse are spaced at 9 inches, whereas in the middle, the main reinforcement D20 reverse are spaced at 18 inches, which means every alternate bar will be individual rebar, uh, which is gonna be just stuck in sticking into the going into the concrete to 1.142 inches. So is that allowable? That's the question I asked Sean Meadows. I'm waiting for the response. And also I asked him, is this 401 rebar, like can this be 501 rebar or 601 rebar? So I asked him that question, just waiting for it. So basically this 401 rebar is acting as an interface rebar, which is a horizontal rebar. So this rebar is kind of acting as a shear stud, like for creating the composite action and also taking care of the horizontal shear, right? So yeah, majority of the bridges I have seen like they kind of match the this hook rebar with the D31 and the D20 rebars. This is a hand 68, and then on Lucas job which I designed when I was with TRC, so I kind of did the same thing. C401 is the hook rebar matching with the D31 at 3-inch spacing. Then beyond 3 foot, then again it's a 6-inch spacing, and then after that you have 1 foot spacing. I try to match the spacing. Yeah, I think that should be it. So that is preferable, but this is not the end of the world when you have 9-inch spacing. If it is not working, you can make it 9 inches. I'll have a different space than the D20 D-bars, which is the main reinforcement. I'll be waiting for a few more, few more. Uh, I'll get some response from Sean Meadows tomorrow, and then see what he says. Based off that, we can say number 4 can be worked out, or number 5 can be used, and so short. In short, this is the 401 is the horizontal interface reinforcement. Your main vertical shear reinforcement in these beams are welded wire reinforcement. That is it. So, and you also have the D20 mat, which is basically connected, which is going along the length of the beam, and then D31, there are 4 D31 rebars going along the length of the beam. D31 size again is number 5 rebar. D20 is number 4 rebar. I hope that clears. Right, I'm gonna stop my recording now.